Hello guys, and welcome to this videocast. I will try in this video to solve some problems. Some of them are going to be very easy, some of them are easy, and maybe we will have a couple of moderate problems. I'm sure it will be split into several parts because of the time limitations on YouTube. So the first problem that we are trying to solve is this one. We have one source and we have this connection of resistors with this one, and we are asked to find the voltage between A and B, the voltage between A and C, the voltage between B and C, and the voltage from D to E. Now this is quite a simple one, and the idea is just to emphasize some of the concepts. Now this whole thing is one node, and the whole circuit can be redrawn in a little bit different way or a more simpler way, like a source and the resistor here, one, and this the 4 kilo ohm is here and the 6 kilo ohm is here, and we have the DE branch here. That's it. So we still have our node or point A here. B is here now. This is B. This is C. And here is D. And here is E. And this is the 20 volts source. So now this guy is 4 kilo ohms. And this one is 6 kilo ohms, while this one is 2 and this one is 1 kilo ohm. So what's this voltage? Well, we learned that parallel branches, this is a branch parallel to this one, parallel to this one, parallel to this one. So all these parallel branches, they have the same voltage, which is given as 20 volts. So from A to C, that is this one, the voltage is 20 volts because it is given as a parallel branch. Now from A to B, we have a voltage divider. This 20 volts from this to this is going to split across these two resistances, and we can apply the formula voltage across the 4 ohms, the 4 kilo ohms, equal the total voltage on the branch, which is V source, times the resistor that we are looking for over the total of the two resistances, that is 4 plus 6. So it is 20 times 4 over 10, which is, of course, there is kilo ohm with kilo ohm, which cancels. So 20 times 4 is 80 over 10. That's 8 volts. That's this from AB, from A to B. From B to C, which is the third one, well, if the total is 20 from A to C, and if we have from A to B 8, that means from B to C we have 12. So this one is 8 volts, this one is 20 volts, and this one is 12 volts. Now from D to E, if we are looking from this side, then it is minus 20. So from D to E, it is minus 20 volts. That's it. That finishes this first simple problem. Okay, so the second example is a conceptual one, and we will have a couple of these conceptual examples, and we are asked to find the voltage between this node A and this point B, the 2 points. Now, if the loop was closed, we should, of course, assume that the voltage should be 0, and it should be 0 because of KVL. But this is not it is not a loop. This is just a one branch with 5 elements, so we can find the voltage between these 2 points. Okay, so VAB equal the algebraic sum of voltage rises and voltage drops. So we have voltage drop, voltage drop, voltage rise, voltage drop, voltage rise. That is 1.5 plus 1.5 minus 1.5, this value here, plus 1.5, this one here, minus 1.5. So the total is 1.5 volts. That's it. Okay, another similar example that falls in this category of fast conceptual ones is related to KCL as follows. So if we remove this one, okay, so in this example we are asked to find the value of the current I2 here. Now this current I2 comes out from this node, okay, and we have two currents entering the node. That means that I2 equals the algebraic sum of the currents entering. Since we know that this current is 10 amperes entering, we have to know what is the value of I1, add it to the 10, and we get what is the value of I2. But I1 comes from this node. It is coming out from this node, where in this node we have 4 amperes coming in, 3 amperes going out. That leaves us with 1 ampere, which is the value of I1. So I1 equal 1 ampere. I2 equals I1 plus 10. That means that I2 equals 11 amperes. That's it. A third example is the following. Now this third example, again, I think we did something similar in the class, but it is good to repeat it because it has a very important insight regarding branches where there is no current but there is a voltage drop. So in this example or this problem, we are asked to find the value of VL. Now the value of VL, or the voltage between these 2 points, this point and this point, is the same as the voltage between this point and this point, or the voltage drop across this resistance, because this resistance plays no role in this circuit since there is no current flows through this resistance. There is an open circuit here, and we said that the conditions for a current to flow is voltage difference plus a connection or an element, and since we don't have a connection here, that means there is no current in this branch from here to here. Since there is no current in this branch, this resistance has no use at all, so simply we can just ignore its existence. So our circuit becomes the following. This one 10 volts, this one 4 ohms, this one 6 ohms, and we are looking for this voltage VL. Okay, now this is now a very simple idea. Either find the total current that passes in this loop, multiply the current with this value of resistance, you get VL, or we can just use voltage divider rule, which says that the voltage across this resistance of 6 ohms equal the total voltage in the circuit, in the branch or the circuit, 10 times 6 over 4 plus 6, that equals 10 over 10 times 6, which is 6 volts. And this should make sense. This is a bigger resistance with the same current going into the 4 and the 6. We are expecting that this bigger resistance will have a bigger amount of the voltage but both of them should add up and give us 10. So the 10 will be split between these two, and this one will have a bigger share of the 10. Okay, thank you for watching, and see you in another video with more examples.